So remember, first of all, it's a curve. Curve, which means is a graph. And then second of all is actually it's going to assess the discriminability of the item analysis or of your items. Although on the packet it do says it's also assessing difficulty, but it's actually difficulty already talked about here, and also ICC is retrieved from IRT, so that's why discriminability.
So it's discriminability and difficulty.
Yeah, but discriminability is more important than difficulty. I mean, after all, IRT already find out difficulty for the items.
What's it discriminating?
Discriminability?
No, what is it discriminating?
Differentiate subjects with varying amounts of traits being assessed.
Yeah, it's on page 96. So it's talking about which,
Yeah.
whether an item can reflect or differentiate. And then if you look at example, I think they use different examples. So on the bottom of page 96, they're trying to say, okay, for example, if this is a task they gave to 1,000 people, and that's how they subgroup them. But then the next on page 97, you may feel like they draw this ICC based on that table on page 96, but it's not.
Oh, it's not the ICC there?
No.
Oh.
Oh, this is not ICC.
Yeah, because you saw like that table, they're supposed to draw the ICC, right, to reflect that table example at the bottom of page 96. But instead, on page 97, they use a different set of actually examples.
Yeah.
So I think that's probably a mistake they made. Just jumping over it.
What's the mistake? I'm sorry.
They use different data.
Yeah, it's just a table.
So this is not the table.
Oh, yeah, it's
No.
just different.
Yeah, it's a different. But I mean, they're supposed to be consistent because that's they're trying to show the ICC, right? Yeah. So if you look at the chart on page 97 on the top, and then on the right, you're explaining how this ICC works. So you can see from the plot that 50%, so 50% is on the left. It's the y-axis. So if you find for 50, that's the percentages that passed item 1. And you draw a horizontal line, and you find that little spots. And then when you pull it down vertical, you're going to find it's 7 under the total score on the entire exam, which is on the x-axis. And that's why on the right it said you can see from this plot that 50% of the students who passed item 1 received around a 70% on the exam. Because it's 7 out of 10, so that's why it's 70%.
Oh,
And also it says starts to discriminate between total score of 5 and 8.
Yeah, because you can look at the trend. So if you look at the scores from 1 to 4, you can see those 4 points, they're almost on the one line.
So
Yeah.
don't you get rid of, so does that mean that you get rid of like 6 through 10?
No, you don't get rid of them because they're the score. You're trying just whether to see your item is a good item or not.
Okay, so you keep
Yeah,
the item.
but we don't know what's the item exactly on the example. It's another mistake the packet is made. They should say what this item 1 means or what's this item 1. Because right now we don't know. But at least from this ICC curve, we're supposed to tell this item doesn't work well for students who score between 1 and 4. Because you see, when they score between 1 and 4, their percent past item 1 is almost the same. It doesn't have a slope. That's why there's no discriminability
Oh,
for the
it
students.
doesn't discriminate well for those.
Yeah, but it doesn't mean that you remove the score. Because yeah, you want to have a slope. So for example, from 1 to 10, you want it like this instead of like this. So that's like 1 to 4, and then this is like 5, 8, and then 10.
So really,
So this one is what you prefer, but this one you don't want. This one is the one that example shows in the packet.
So what do items, because there's a 0, okay.
rather than just
Yeah, so because we don't know what the item is, we
But
didn't talk about it. Just use the scores to assess the difficulty and the discriminability of this item.
So if I'm understanding correctly, an item analysis would be useful for this comp, really, to select
Right.
appropriate questions rather than randomly.
That's why they.
Exactly,
that's why-
yeah.
That's why they don't give us our score
That's
right
right.
away, I
Yeah.
guess.
Exactly. Yeah. Actually, that's a good. You're totally get it.
I'm
Now.
under
Is
the
this
impression
recorded?
that,
Now it is.
I was under the impression, if I'm reading, that the item 1, because they put it into subgroups of the people, so these are all the people. I know
No.
it's a different example, but based
It's
on what
supposed
the
to be.
chart's saying.
Not really.
For item 1, they put random people.
Because if you look at that, it's I
I know
think
it's a
it's
separate
different
chart,
sets.
but if you were to graph this chart, so I was under the impression that 50 subjects, out of these 50 subjects for item 1, 2% got it right. Oh, these are all item 1, I see.
yeah, they're all item 1.
Oh,
Because like, for example, we have, let's just say this example, let's just say we have 100 students. Each of them take the item.
Yeah, okay, so
Yeah,
this is all
and then
item one,
actually,
you're right.
yeah, so when we say that percent that passed item 1 is on here,
That's what I was
so
gonna-
the 0% is actually is they fail. So actually if you see pretty much all of them passed. Yeah, because they're all above 0. So actually they should draw the chart like this. So this is 0 and that's maybe 50, 100, that's past item 1. And then they should put like maybe negative 10 or something. They should have some people under 0. So you know that these are items that students failed. They didn't pass the item. But actually if you look at the chart, everyone is above 0. So everyone passed the item. So yeah, so if you really say that this chart is not really assessing difficulty, but then however on the packet it says that, oh, it tells you the difficulty of the items. But the difficulty should assessing like whether you pass or fail, but
it's to compare it, probably if they kept doing each item like this, and you compare that way you can see who your top performers are and which ones of those top performers also missed that item.
it could be, but like under this case, everyone is above
I
0.
think Heather's right.
Yeah, everyone passed the item.
Maybe we need to progress. Yeah, sure.
But as long as we know what it's talking
But
about,
when you have a
like
question, we'll
generally,
stay on it.
but at least the slope is correct. Because after all, the slope talking about the discriminability is very accurate. So between 5 to 8, you starting have the slope. That's why we say starting only at like score of 5, they're showing the discriminability of this item.
Okay.
So which means if you're trying to, so for example, if your participants, they're all between range score of 1 to 4, you cannot even use this item. Because you just showed from this example that students who score 1 to 4 doesn't have a discriminability of the item. So which means, let's just say today you go outside, start using this item or this question, which is also item means question under this case. So you ask these, let's just say 50 students, but unfortunately you don't assess their scores. What if their scores is between 1 and 4? And you ask them this question. This question not going to reflect anything
Yeah.
because it shows here that it doesn't have a discriminability. You cannot find out anything based on that question if you use these 50 students. So that's why you see you do item analysis, you do IRT, ICC, you'll find out this.
So you would not keep that item?
Or you can make some adjustment and redo this again.
Okay.
And then trying to make the item not that difficult and have more discriminability.
Okay,
Yeah.
okay.
That's the whole point.
So you would redo the item?
Yeah, you can add it and then just either change it or modify it. I mean, after all, you may still want to keep that item. For example, what if its reliability and validity is really good? Right? That means it's still a good item. And if you go following on the packet on page 97, and actually that chart, that is the true ICC curve, so they draw like this. But actually this one is not the one referring to the diagram
Right.
here. It's totally wrong. Because they said this is a very bad situation as students are scoring higher on a test, they're failing item, which is wrong because every people on this chart, they're all passed item because they're all above 0, which means they didn't fail the item. But of course, if you just look at this ICC curve separately, it makes sense. I mean, the content is correct. Because if you look at this ICC curve separately, not linked with this example on the above, it is right. The more percentage in passing, the lower score they're having on the tests.
For that one item, question number 1?
Yeah, so don't look at it. If you just simply look at this, it makes sense. But if you connect them together, it doesn't make any sense
Because
because
it's a negative
they're making like reverse results between each other. Yeah.
inverse relationship.
So this is the right ICC curve. When you draw ICC curve, it's supposed to be like this. So it said percentages of passing the item, and that's the total score. And if you look further, so that's a different pattern of ICC. So you can look at it here. It means with the poor scoring students, their passing keeping crazy. But then when they score higher, their item passing percentage is exactly the same. They don't really show any discriminability. And vice versa for this, poor students, is actually this one is a perfect reflection of our example here. So this is supposed to be the right one to reflect this example, not this one. And after that, if you go to the bottom of page 97, they're talking about the advantages of item response theory. Yeah, I didn't write here, but just make sure you just know there's some advantages of doing that. But if you really say that this is actually, it's a better systematic theory, you're trying to do both parts of the item analysis. I mean, you can do this separately by not using IRT. You can do this too by yourself. You can come up with a way or method to do it. But IRT is a more systematic theory. That's why it has these advantages listed out in the packet.
Better than just performing a difficulty and discriminability.
Yeah, by yourself. Yeah, you can use
Okay.
different methods or ways, but this is a systematic way that statisticians find it out. I list all the assumptions here. It's on page 98. It's on the top. Because assumptions here are really, really different from the assumptions we talked about earlier. So yeah, you just quickly read it through because it's not really that difficult. So there's only 3 of them.
Where?
First of all, yeah, it's on page 98.
Top of the page.
Yeah.
Unidimensional?
Oh, what is unidimensional? Oh, just one construct, one. Very
Actually,
clear construct.
unidimensionality is it's construct to multidimensionality. Actually, that concept I can explain better in the SEM or path analysis. Unidimensionality means that actually they can only be loaded with one thing. So you can say this: a kid's biological parent can only be one person. Like biology mother can only be one person. It cannot be two. It cannot be 2 persons. That could be a good example to explain unidimensional. It's like one.
So only one thing
dimension.
causes it.
Yeah. And then also it requires a large number of items, which means for each variable, you need at least to design questions to assess that variable. So for example, if you want to measure depression, you have to make sure you can create 20 questions to measure depression. Yeah. That was the second assumption means. And then the last one, large number of people. So when you're trying to do the item analysis, make sure you have at least 400 people to answer those questions you created. You can have more, you can have like 200, 300, the more the better. Because you can find the best way to check its difficulty and discriminability. And after you check these 2, the third thing you need to do is for chance under item analysis. And chance here is actually, you can understand it on its common way. So chance means that you want to make sure the item you created, like when you assessing its difficulty and its discriminability, you want to make sure that this item can be actually generalized to every single participant you're trying to assess. So that's the chance issue. You don't want to say that, okay, for example, if today I do 400 people, these 400 people have a great difficulty and they assess the great difficulty level and discriminability level of my items. But the chance here means that this 400 could be extended to 1,000 or either more population. So you see, after you go through chance, that means your item, or the skill, the inventory you developed, can be applied for any people. So that's why I say these days BDI, because we know that it's a good skill, it's a good inventory, and we know that it can be generalized or popularized to use for any type of depression group of people in the psychology field.
Is that true only for this country, for like Western?
Oh, like
Sure.
for like American. It could be for international design, but of course, you know what, you can do this. Because like you can also find out whether there's some like current psychological skills or inventory, maybe not BDI, maybe other things. You can use them to test whether it's only applied nationwide or it also can be applied internationalized. Yeah.
Can you explain this percentage occurrence agreement, percentage non-occurrence reliability? It's under chance.
Yeah, I saw it. I think, well, I don't really, like I said, because this one is not really covered in business
Oh, okay.
statistics. I will say like this chance is more like reliability testing. Is to see how your in items or your skills inventories you're trying to establish can be used like for more generalized about population. If you go to the reliability section, you may find these like connections between each other. For the chance here and the reliability we were talking about earlier.
They say you use kappa or kappa.
Yeah, they use Cohen's kappa, like we talked reliability on Saturday.
Okay.
Yeah, because I think that one gave a good, because they mean the same thing. They talk about the percentage currents agreement, non-currents reliability agreement. But I wonder the packet gonna came like lots of questions about item analysis. Rena, can you help a little bit?
With
Do they- the comms you took, does it give like questions about item analysis?
Nothing.
Nothing? Oh. So actually I would say, yeah, I would say
Wow.
this is not really like
Well,
important
but
section.
again, they choose different.
Yeah, of course it changed, but I would say that you don't have to go like
Okay.
further with detail. If you really feel like you're stuck at this point for some of these like not really important things, you don't have to go
Like Dr. Goodrich said that we have like only like 2 or 3 questions for like the decision tree, they're not that
Yeah.
complicated.
2 or 3?
There was 5
Yeah.
at least, maybe
Exactly.
7,
Yeah.
yeah.
And the whole point, yeah, because the whole point is to pass exam. And I can tell you that this one could cover only like 5% of the test.
Mm-hmm.
Yeah, so then you know that you just need to pass the exam. You don't have to score like 100%. So you can totally let this focus on it. Yeah.
74% is
Exactly.
American in my book.
Yeah.
Not really.
Next thing is the homogeneity. So this one we're using Cronbach's alpha. Cronbach's alpha. It's also on page 98. It's the next one after chance. So we use this to assess the different facets of the same construct. That's what homogeneity means here.
Different aspects,
Yeah, different facets
facets.
of the same construct. The construct here is the total scale or the inventory you're trying to establish or develop.
What do you mean by different facets?
Okay, so for example, depression, you know, for example, today, we're trying to say depression can be determined by, let's just say your,
Sadness?
yeah,
Could be the mood or the behavior. the different
Depressed
facets.
Motivation.
Yeah,
yeah, like just say motivation.
different facets of the same thing.
Depressed
How many-
mood,
How many
Yeah.
size you take?
depressed mood.
Like
Okay.
Bert's, he'll measure your
Depressed
size.
mood. Is there any psychological?
Fatigue.
How much
What?
Fatigue.
ice cream would you
How to
have?
spell it?
FATIGUE.
Yeah, FAT. that's it.
Oh, okay. So all this could be a separate inventory you're trying to measure at this. This is the construct,
Uh-huh.
and these are the facets.
Now, how does that work if it's supposed to, an assumption is that
Yeah,
it's
so when we talk,
unidimensional?
yeah, when we talk homogeneity, we're talking about the Cronbach's alpha here has to be at least bigger and equal to 0.8.
The Cronbach alpha?
Not 0.3. Yeah, the Cronbach's. This is not a headline error, okay? This is the Cronbach's alpha. I just saved the writing. So you want to make sure when you check the Cronbach's alpha between these two, has to be at least bigger or equal to 0.8, and the same thing here between these two.
Oh, strong,
Yeah, so they have the high homogeneity. So that's how that means these
Highly
facets
similar.
can all belong to this construct.
now how does that work with the unidimensionality? Because that's more than one dimension.
Yeah, unidimensionality is for really for chance. It's
Okay, so it's
yeah,
totally
for,
separate.
It's for assumptions here. Yeah,
Oh,
it's
is
not
that
part of
item
it.
unidimensional?
Yeah. Item means like motivation. Yeah, for example, if you have like item 1 here and you have another item.
Got ya. Okay.
So this item can only be used. So this
Right.
item cannot be replaced by other.
Right,
That's
okay.
unidimensionality.
Thank you.
So let's just say facets have, let's just say, maybe 20 items. And then this one may have 15, and this one may have like, let's say 10.
Mhm.
So you run the item analysis of this to test motivation first.
Right.
And of course, you can combine your different facets to come out the final ultimate construct,
Uh-huh.
inventory or skill.
Would you add those to get the 0.8?
Oh no, the alpha, yeah, these two, between these two, you check the Chromebox alpha, which is here, to make sure that is achieve homogeneity. Because you want to make sure, after all, they're similar, which means they can measure the same construct.
That's if there's only two.
Oh no, they also check
as many
these
as you
two. They
have.
also have- Yes, as many as you
Oh,
have.
you have to
facets.
check it between each
Facet.
each pair,
Facets.
possible pair.
of
No,
facet.
it's not possible, it's called facets.
Each facet,
Yes.
motivation with mood,
Yeah.
mood with fatigue, fatigue with motivation.
Okay,
Yeah,
so you do it
could,
for all
you could have
the
other things.
combinations.
Yeah, so you have to make sure each of them has an alpha. This one has an alpha, this one, you also check their alpha.
Okay, got it.
So you make sure they all have different Chromebox alpha.
It's different than the partial thing that
And
you're
do
referring to
the facets have to be similar? So in other words, I mean, that's what
Exactly,
we're measuring,
yeah.
so.
That means
we're
they can
looking at
measure the
facets
same
for
thing, right?
motivation, right?
Exactly.
And then you do another one for mood, and if those group together.
Yeah, so you do this with this with that. If you
Thank
have
you.
more, just do each of them.
That's why it's Greek.
But all three together would not be, yes, just for motivation.
Okay, but like I said, it's not really a huge important part. As long as you understand what it means, you just skip.
And I will forget it.
Okay, next thing is test bias. It's from page 99 to page 100. So this part is actually very easy to understand. Just make sure you assess the phase content validity, which is similar to the validity we talked about earlier. And then there's item bias. So for example, if you're trying to do different samples of population to see whether their demographic characteristics could be a problem for test bias. So the example shows here, if you're doing the test for Caucasians, African American, or Pacific Islander, they show different ICC. So maybe it's not your item's problem, it's just because your different ethnicity shows different demographic features on that. So that's a good thing to say that whether we can really put your item or inventory to international bias based or only domestic based. Because you're trying to judge on their different ethnicity. And then there's also slope bias. So if you look at example, they say that GRE could be a good one only to predict graduate school performance for US born students instead of for foreign born students based on the first chart on the left. But if it's the right chart, then you can use for both.
So, on that, this is one of the questions I had, one of the many on the practice exams. I kept getting intercept and slope bias confused.
Yeah.
And so when I'm looking at it right here, I feel like I understand it, but then when you
Yeah,
ask me
so
later, I guess I
slope bias is whether they have same trend. So this one is definitely a slope bias. Because you see, they don't go the same direction. But the intercept is actually whether they have this, whether they're close to each other. So because intercept is on the y-axis, this is what we call intercept, right? Whether they have the same interaction on the y-axis. So the more these 2 points are closer to each other, the less intercept bias they have. It doesn't matter whether they have a slope bias or not. For example, let's just say this one have both an intercept bias because this is a huge difference, and also the slope is totally different. This one is really like go lean up forward. This one is very flat. So it has both bias. But if today, if I draw like this, it has no intercept, no slope bias because see the intercept is very close to each other, and also they go the
But
same
if they
trend.
started off the same and then one went down, the other one up, then that would just be
Just be slope bias, yeah. That's the difference between slope and intercept bias. Yeah, intercept is look at the y-axis to see whether the two interaction points is close to each other or not.
Would a verbal example be like for foreign students, this is when they use,
Yeah,
the range would be 25 to 50% have a chance at passing, whereas the American students have a 50 to 75% chance?
yeah. That would be actually an
Intercept?
Yeah, intercept, yeah.
So on page 99.
Yeah, page 99 talking about slope bias, item bias, and on page 100 talking about intercept bias.
So this one does have slope bias and this one has no slope bias.
Yes, that's right. And then after intercept bias, if you go down on page 100, they're talking about psychometric equivalence.
That was a break.
Okay.
we go. All right, so after item analysis, you see after you establish your items, so let's use BI. Well, probably not BI. Okay, I'm gonna use BI. So this is your construct. And let us say you create a new scale to measure motivation.
She look like me.
We're still under,
You have more.
where are we now?
We're done with item, but let's just say after we do item analysis, you fill out a new scale. Maybe let's use a different name. It's not called BDI.
You're talking about what now, principal component?
Yeah, I'm talking about this, but I'm just trying to say what's the
okay.
relationship between these two. I'll just give a new name, because after all, you create a new inventory. So instead of using BDI, we call it new depression. So that's your skill you developed. And based on that, as your construct, you also find out your motivation has, like let's say, 20 items here. And your mode, let's say you have 15 items. You all create this, and you pass down with all the item analysis procedure. And for A, you have like 25. And after this, actually you're supposed to go through principal component analysis to actually clarify these items for each of the facets here. Let's call it facets. You can change the name later. So you have 3 facets, 1 construct, and that's your different items. So total you have like 35, yeah, like 60. You have 60 items total to measure new depression. So actually the principal component you can do for the total 60 items, or you can do for each of the single facets items. So which means how many actually component factor, principal component analysis you can do.
Oh,
Like I just explained. You can do for the construct, you can do for the facet.
4 or
Perfect, yeah.
construct and.
So we're on, I'm sorry, I was really not,
Oh,
to be honest. Okay,
We're
so
on
what
principal.
are we doing? Principal,
Mhm.
component.
And actually, you not only 4, you can do more than that.
And combinations?
Yes.
Okay, can you describe what you just drew again? I'm sorry.
Yeah, this is from item analysis you just find out. That's why I'm just trying to explain how you can go from here to here.
Okay, so we haven't gotten on PCO
Yeah.
yet.
So actually you can do 4, 5, 6, and 7. So actually you can do 7 principal components.
Because you can do the construct by itself.
Okay, so first of all, you do the depression principal component. It has 60 items, so that's the first one.
Oh, okay.
Second one, you can do each of them. So you do a 20 item, 15 item, 25 item.
Mm-hmm.
And then the 5th one, you do only these 2. So that will be 35 items.
Can you repeat what you're saying?
Okay.
Yeah, that's what principal component will do. You can't,
that's
you don't
it?
have.
Can you
No,
say it
You
again?
have the 6. These 2 you combine them,
She's
so
saying
that'll
you
be
can
15.
do each
and that's
one
gonna be
by
40
itself.
items.
Or together.
And
The
you can
whole
do the
construct
7th.
or
it can be
any
45
combination of
items.
each
Oh,
facet.
okay, so let me
Yeah.
write this down.
So that's why I'm trying to explain what's the difference between these 2 and also the connections. So here you just create items. After you create items, you use the principal component analysis to clarify these items to see whether they are the truly items to explain your facets here. And then further you can do them for path analysis or SEM to do like a statistical tests to really put them into your real model and then really use them in your dissertation.
So you
After
are,
all, you develop this new scale of yourself. Yeah.
so you're clarifying the facets by combining the items?
Yeah, you can, because under this case, because you haven't really to say that this is a determined construct, right?
Mhm.
You just simply based on the previous theory or previous literature, you develop this scale based on whatever you believe is true.
Mm-hmm.
But item analysis cannot go further to say that, okay, these 25 items are truly items for Forte.
Mm.
Yeah, that's what principal component
Okay,
or
Would
preferred
that be the
analysis.
confirmatory
Oh,
part
yes,
if
that
we
was
wanted to do it?
But
So
that-
we.
okay, that's factor analysis. But I can
later.
tell the difference between this. Right now I'm talking principal.
Okay.
Principal can do combination, can do separate. can do all.
That's right, it is.
Yeah. Because you're not using principal to really confirm the factor or the structure, or the construct, sorry. So that's why you have 7 possible principal component analysis you can conduct. Depends on how you want to do it.
What page is it on?
Oh, actually, principal components is on page 74.
Oh, thank you.
7 possible for the example you
Possible
gave,
differences.
but not necessarily 7 for every single one.
Yeah, you don't have to do them all. It really depends on your need. Yeah,
You can have
yeah, you can
7,
have
but
at
you
most
you don't
7.
need
Yeah,
to.
you don't
use
need to
7.
do all of them. But I'm
Right.
saying that if you theoretically to say you can conduct 7 different principal component
If
analysis
you
out
had
of this.
6 facets, it would be different.
Yeah, if you have 6, that's even more. Yeah. But this one is not covered in the packet. You don't need to know, but it will be helpful for your dissertation. So the principal components is from page 74 to page,
That's it, just page 74.
It goes all
actually,
the way to 77, I think.
it's actually to page 76.
Oh, okay.
Yeah,
After the bonuses and 77.
I would say yeah, to go page 76. Because actually these two, they're a little bit hard to distinguish between principal component and factor, but I'll explain that later. Okay, the key points in principal components. This V here is versus.
So the first one is principal component
Yeah,
versus.
principal component versus principal access factory. I think I spelled it right.
The part where I'm so tired already, I couldn't.
About type.
No, I'm talking about when I was studying this, it's just so.
Oh, yeah. Because that, like I said,
So much.
this section is so different from whatever the analysis we talk about earlier. That's. Okay, I'm ready to talk about. The order on the packet is a little bit different from the order I talk about here. I just do this one because it's also following the procedure when you do the principal component analysis. You're supposed to follow the steps like this. But the detailed contents you can refer to the order of the packet. So the first thing you need to know is that the difference between principal component and the principal access factory. Because actually these two are part of the analysis of principal component analysis.
They're both part of PCA?
Yeah. Yeah, they're just different methods. So the difference between these two, this one is actually on page 75, and they only use a A. It said A principal components versus principal access. They don't even talk about it. They just say you have to know how to tell the difference. Somehow they just assume you're supposed to know instead of saying anything. But I'll tell the difference. The only time that you're going to use principal component is when your items are less than or equal to 50. That's the only difference you need to know. So let's just say you can use, pretty much you can still use principal component when your items has more than 50. But the chance is that you're not going to have a good results coming out from principal component analysis. So you can know that this one is less conservative and the less strained. Strained? Let's call that.
Stringent.
Stringent. Thank you.
G-E-N-T, yeah.
When it's less than 50 items, you use the principal access.
Yeah, that also means that this one is less conservative and less stringent. You can still use this when you have items more than 50, but the chance is that you're gonna have like more biased results.
For items.
No, for your for your components.
Okay, so if you have less than,
Yeah, so if you go out here,
you
let's
have
say.
less than 50, use the principal component analysis. If you have
Yeah.
more, use the principal access
principal,
factor.
Yeah. But like I said, if it's over 50, you can still choose to use it. It's not to say you cannot use it because these two, they're not really that different. But the thing is that this one doesn't not gonna give you a good results if you have more than 50 items. So let's say here, this one, you're supposed to use principal access, right? Because it has 60. This one you can use both principal access and the principal component.
Oh, okay.
Yeah, but the 15, principal access, principal component.
What do most researchers use?
Yeah, so when you have less items, like I put it here, you use principal
Okay.
component.
Because it's more stringent, you have less.
Exactly.
It's kind of like having less N,
Yes, that's true.
so more power
Yeah.
sensitivity.
Exactly. You can use both actually for any type of a case regarding the items number. But like I said, one of the researchers find out that less items works better for principal components and more items works better for this. Yeah. That's the only difference. And the packet doesn't talk about it, but they list it out like an important thing.
Good, thank you.
Yeah.
So that's it? It's just the difference between the item
Yeah.
number?
They don't really have that much of difference, technically to say. Okay, the next one is communalities. It's on page 75.
And this is still all under PCA?
Yeah, PCA, that's right. Let's give it, I'll call PCA. So communalities on page 75.
Smell.
So actually communalities is like
Communalities.
equivalent to R squared. Oh, not R squared. It's equivalent to beta. Let's use the BB. It's equivalent to beta, which is, we talk about in multiple regression, the standardized coefficients, which is also the individual contribution of each predictor kind of counted for the variance of the DV or the outcome. Except for here, when we're doing principal components, we don't have
Did
predictor
you
or
contribute
outcome.
of the DV or the EV on the DV?
Yeah, but in principal component, we don't have DV or IV or anything. We call them factor, right, components and items. Yeah. So here is like similar. It's going to be to say the variance can be explained in the component by the item. So which is communalities.
Individual variance accounted for by each predictor on the item or factor?
Yeah, it's similar to that.
So it's
By the way,
the
we're not
contribution
supposed-
of
we're not
the
supposed to
variance
say
of the
predictor.
component on the item?
No, the items on the component.
Okay.
Variance of the component explained or accounted for by the item. Yeah, that's why I say it's similar to beta, because that's also the variance on the outcome can be explained by the predictor. So if you look at the packet, explain what's the low communality means and what's the high communality. And of course, you always want high communality, because that means it's efficient items. It do explain.
Can you give an example of communalities?
What's the page?
It
Yeah,
would be like.
It's like 0.729. And then, so for example, if you have 20 items, I just say we do the second one, we have 20 items. We
Okay.
do for motivation. So motivation is your component, right? And you have 20 items. So let's just say this is item 1, item 2, and go like item 20. And SPSS create a table, it's called communalities. So you have this variance here. So that's what I'm saying, it's like beta. It's always less than 1. So 0.728, 0.608, 0.419, blah, blah, blah. And you may have something like 0.1, like 0.021. So that means this could be a bad like items to the component because it doesn't have a high communality to the component, which means it doesn't really explain the component.
Right, to get rid of it.
Yeah. So these are called items. It's each of their single question.
For instance, the 0.021 could be on that component if we're using mood.
Modal, yeah.
You have a
It
cutoff.
could be like how often do you ride a bike?
Exactly. Yeah.
Right.
Yeah.
So that relates
very,
to the
very-
component, which is
Yeah. So these
a
are
part of the
components,
factor,
a part of the construct.
the construct. Okay.
Yeah. So that's why, see, we call them facets when we're doing item analysis, But when you go for principal component, this
It's a
one's called
component.
component. And if you go factor analysis, this one called factors.
Factors.
Yeah.
Wait, so it's a synonym. It's just different.
Yeah, it's the same
methods.
thing, but
Cinnamon
it's
sounds good
it's
too.
different names.
Okay, so
It's like a male can be man, can be boy. They just talk based on the
You
different
act like it.
situation. Yeah, but they all mean the same. Okay, next thing you need to know is engine values or script plot. This one is important because we use this one to decide how many factors or components, because we're doing components. How many components you're supposed to came out from the items you're trying to study here.
Supposed to retain or?
Yeah, retain, that's right, retain or obtain. It's on page 76. Because this one talk about the total variance. Remember, this one is each single. So actually this one, if you say it's equivalent to R squared, because that's the total variance, can be explained by all the items to that one component. Because beta is each single variance can be explained by the item to the component, but this one is a total variance explained. So that's why it's similar or is equivalent to R squared in the multiple regression.
Total variance explained by the component.
I
No,
thought
total variance
principal
explained
component.
of total variance of the component explained by all the items.
I thought principal
Variance.
component analysis is
Oh.
explaining all the variance. I thought that's its job.
Well, you can say that, but pretty much we use principal component is actually trying to see whether these items are like legit items.
I think, isn't eigenvalue only for factor analysis? Because it says eigenvalues is statistic used in factor analysis to determine how much of the variation in the original group of variables is accounted for.
That would
Particular
make sense
factor.
to me
Yeah,
because
it's for factor analysis.
his factor analysis only explains the shared common variance between the variables used.
But actually, that's the point I'm saying. If you look at page 74, that's one thing. When they're trying to tell you the difference between principal component and factor analysis, they're saying that actually they're similar. That's why they do talk about every single thing they talk about here. It just actually factor analysis is more consolidated, it's more detailed, and it has a high validity and reliability issues than just a simple principal component. Okay, that's what I'm saying here. Principal component can do 7, right? If you really want to, you can do 7. But the factor analysis, you can only do 4. You cannot do 5, 6, and 7 for factor analysis. Because after principal component, you have to make sure either you're trying to identify your construct, you identify each single factors after you're done with this. So for example, if you do like a 5th principal component, you find out it doesn't give out good results, and then therefore you know that these two is 2 separate factors. It's beyond the component's concept. So that's why when you do factor analysis, you know that you can do motivation and the mood separately as a single factor. But what if you run a principal component analysis of 5 when you combine them, and you actually you find out it came out 3 components. So which means there's something wrong with the factor of motivation and mood. And by using a principal component, you can clarify this out, and you find out there's supposed to be another factor. And after that, you go further to factor analysis to identify this as third
The
factor.
factor analysis would
Yeah.
miss that.
Exactly.
Okay.
Yeah.
False
So that's why
positives.
principal component is supposed to have engine values, because you use engine values to determine how many components you can have here. Yeah, I know the packet is kind of like talking weird.
So the
thing.
engine values is what tells you how many factors you can have?
And then
Yeah.
the factor will determine how many factors it can.
Yes,
Just
factor analysis.
Talking about
Yeah.
Using a different way of
Exactly.
factoring.
And the factor analysis can help you to
He
delete
calls
items.
Factor analysis and PCA together.
Yeah, but it's supposed to be because it's supposed to be still able to do it and to see whether the 2 components is actually supposed to be 3 components, And then you can go back here and then modify this, and then finally go to factor analysis to delete the unrelated items, and then to really like extract it better. And then you can use the true variable for either path analysis or SEM.
Okay.
Yeah.
Because I guess one reason why we might be confused is because we were kind of taught that they weren't in step, but they were set. We had a choice, kind of. which one,
Exactly.
depending
Yeah,
on the
that's
model.
right. Yeah, of course, principal component has like less power than factor analysis,
Uh-huh.
but it still can do this. Yeah, it's part of a principal component analysis. Yeah.
To tell us how many factors we need to have is different than to what factors we need to have.
Yeah, because when you do factor analysis, actually you're trying to see how many factors you have, and then you can see that these factors are the true factors for the construct. Because after all, when you run the item analysis, this is like a temporary
Right.
pattern for
We'll say
your
7 of them or whatever.
Exactly. And then you do a principal component trying to extract this. Because this could be 3 or 4 or 5 after running a principal component. And then after that, you do a factor analysis to delete the unrelevant items and to build a better connections of this whole construct. And then you throw it into your research model doing these two analyses here. Yeah. So actually engine value is supposed to be part of it. And then we know that engine values need to be then bigger than 1.
Yeah.
To extract the components or the factors we need.
Is it equal then and greater than 1, or just
It's-
greater than 1?
Yeah, greater 1, no equal. Yeah, just greater than 1. And then the script plot is just a diagram or graph pattern for the engine values. They don't have a difference. It just script plot shows in graphs of the engine values. And this is total variance explained of the component or the factor by the items.
Say that last sentence one more time, please.
Oh, okay. Engine values is the total variance of the component or the factor can be explained or accounted for by all the items.
That makes sense, yes.
Total value.
Variance, yeah, or you can say total shared variance of the component or factor can be explained or accounted for by all the items.
Okay.
Yeah,
Gestalt and symbol.
By all the items.
yeah, all the
total.
items.
Okay.
Yeah.
This is Gestalt. This is not symbol.
Okay, so it's an R squared, equivalent to R squared.
Yeah, equivalent to R squared.
And R squared is in multiple regression.
Exactly, that's right.
Yeah.
Gestalt.
So you know that these things, you use them for principal component, but also you use them for factor analysis.
Okay,
Yeah.
wait, what things?
All of these key points here. Yeah, because you guys kind of like jumping a little bit forward, so that's why I'm going to talk about these two together. Because actually they're supposed to be the same. But the only thing that factor analysis is a little bit beyond the principal component. It's more complicated and it's more, it's like more powerful than the principal component. Like I said, principal component you can do any single combination of the items. But then factor analysis is after you identify your construct and then you do each single factor. You can do the whole construct.
And you said factor analysis has more power, or what did you say about that?
Yeah,
Yeah.
it's a more powerful.
I'm confused why it's more powerful if PCA is more sensitive.
PCA is not really sensitive. PCA is like, it's more conservative. It's not, instead of to say sensitive.
Mm.
Because PCA, that's why we say it's a component. It's like, if you're referring to component factor is more identified. It's like identified well. And then when you're doing factor analysis, you can delete items.
Okay.
Because if you run the method, you're going to find out actually you can delete items that are uncorrelated with that factor.
Okay. you
But a
can't-
component analysis cannot do that.
Okay.
Yeah. That's the ultimate like difference. Yeah.
Got it.
And the next thing is rotation. So here. Yeah, okay. It's on page, let's go for page first. The page is on page 75 to 76 on the
Raina, is there
top.
a lot of rotation on the test?
I don't remember.
So when there's rotation, there's one thing that Asher talked about on Saturday.
Cried about.
Oh no. I'm
What?
sorry.
That's right.
It's
G
over
O
there.
L A L.
Yeah, okay.
It's because it's not a real word. Except for in
Or
stats world.
the wall.
The pinnacle.
Oh, yeah.
Those are easy points on down for the tests. You can just remember which test goes to which one.
So this is how I did it visually.
I remember
Like
seeing.
I remember that.
Yeah, I just didn't know.
Oh, okay. So the reason actually we do rotation, I don't think the packet talk about it quite right. It just said any of several methods in factor by which the researcher attempts to relate the calculated factors to theoretical entities. Well, it makes some sense.
So you use rotation for what?
Rule of 75.
I'm just reading the packet.
Yeah, but what does it say?
It said any of several methods in factor analysis by which the researcher attempts, by transformation of loadings, to relate the calculated factors to theoretical entities. But actually, if you say mathematically, rotation doesn't do anything differently than actually engine values.
Okay,
Because
hold on. Can you say it again?
and before the rotation, remember when you draw the charts, there's your, like, let's just say factor here. And remember, rotation is the one for factor analysis. So you stop at engine
It
values.
has to be
for
higher than
component.
one that's for rotation?
No, for engine value.
Oh, okay.
Yeah, sorry.
What'd you say mathematically? Oh, then eigenvalue.
Eigen or engine values.
And rotation is only for what?
Yeah, it's only for
Factor.
factor analysis. We don't use that for principal component. So let's just say this is your factor, and that's 1, 2, let's do 3. No. Oh, I should put factor here. It's on top. So that's your factor. And this is your item. You have 1, 2, 3 till 20. So you have factor 1, factor 2, and then so each of them are going to have actually a factor loading. That's why factor loading shows in this table.
Oh, it's how much that
0.7.
item loads on that factor.
Exactly, that's what actually rotation will do. So let's just say before you rotate, it could be like this, 0.6, 0.7, 0.3, blah, blah, this one could be 0.8. So actually, if you look at the before the rotation, SPSS will create a factor loading table, but actually you're going to find out that most of the loading is on factor 1. So actually factor 2 is like 0.3, 0.2, and 0.1 something. This actually is very low. So this is the before the rotation table. The only reason actually they do rotation is actually they designed that for SPSS procedure specifically. That's why it doesn't have any statistical reason to do that. It's not like you have to talk about R square and the beta because it means different things statistically, not only mathematically. But under this case, rotation is designed for dealing with these SPSS issues. Because if you before do the rotation, every factor is loading on only factor 1. Every item loading on factor 1. They don't load on factor 2 and 3. So you cannot tell which factors goes to which factor. So that's why we do a rotation. And then it's still items 1, 2, blah, 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 till 20. But then there's going to be change. So this is the factor rotate. And then it's going to be 1, 2, 3. And actually you're going to look at the score is that, for example, this could be 0.2, 0.3, and then 0.7, 8 something. This one is 0.7, 0.8, 0.6. And then this one is like small loadings, but then here is 0.7, 0.8 something. So actually you find out that the middle items loaded on factor 1, and then the first items loaded on factor 2, and the bottom items loaded on factor 3.
That's right.
That's what rotation do. They just redistributed loadings and then put it like on the factors they're most highly correlated. So that's what rotation will do.
Can you just pause so we can write all this down?
Sure, yeah, go ahead. I'll pause. I will pause. But I just want to know that rotation doesn't do any amazing job. It
So
just
can you explain that top one again?
Okay, this is the table. If you do before the rotation, this is a table created by SPSS.
Okay.
It's just called the factor loading table. And then SPSS automatically load all the items on the first factor, no matter that first factor is what. That's what they will do.
Does it always does that?
Yes, always. SPSS
okay.
always does that.
What do you mean loaded all the items?
So which means only factor 1 has the highest item loading. Factor 2 and 3 only have like, for example, 0.2, 0.3, 0.1. It's very slow, right? It's
It
not
became
even.
a socialist. So factor 1, early bird gets its worm type of thing and took all the high loadings.
Yeah, It take all the loadings.
So then the socialists came and Robin Hood came and divvied it out to
That's
the
right.
rest.
Exactly. You can use that actually. That's a good one. Yeah, so factor 2 and 3, no matter what factor it is, it doesn't load anything. Like
Okay.
SPSS just do that automatically.
So what number should be under factor 1 right there?
Just make sure they're all bigger than 0.5 because they
Okay.
always give all the loadings to factor 1. So it's always the highest loading.
So rotated item values must always be 0.5 or greater.
No, an efficient factor loading is always be bigger than 0.5.
Okay.
Yeah. Or a valid factor loading always be bigger than 0.5.
Okay, so
You don't have to know
all-
why, that just SPSS does that.
They all go to factor 1.
Yeah. And they don't care what factor 1 is. It could be anything.
Is it an oblique or an orthogonal rotation?
Oh, it hasn't done with that yet. I'm just trying to do why they do rotation. I'm still explaining what rotation is. So you see, because SPSS did this, that's why you need to do rotation.
Okay.
You see, it doesn't have any statistical reason. It's just purely mathematical reason. Because from this, you cannot tell, okay, then which items goes to factor 2 and 3? You don't know, right? Because SPSS doesn't show you. That's why you have to rotate it. So after you do the rotation, it's a kind of sort of mathematical things they've done with the SPSS program. And now they show you where factor is gonna load on which, which item's gonna load on which factor. And then here you're gonna see factor 1 has some loadings very, very high, bigger than 0.5. But some loadings is very low, it's like between 0.1, 0.4 something.
Who determines the cutoff? We do, it's 0.5?
No, the computer.
It is 0.5?
Yeah, SPSS data. Oh, no, the 0.5 is determined by us, sorry.
By
That's
stat.
Yeah, I thought you were talking about who would determine which items.
Okay,
goes to
so
which
in that example, can you explain the numbers on that example?
Yeah, so for example, factor 1, these numbers are very small, but for the middle items, the numbers are very high. They're like 0.7, 0.8, 0.9. So that means these items in the middle gonna be loaded on factor 1.
I see.
Yeah, and the same thing with factor 2. The top items has the highest factor loadings compared to the other items loadings down here. So that's why the top items loaded on factor 2. And then for factor 3, the bottom items loaded on factor 3 because they have the highest factor loadings there. So that's what actually rotation will do. So now you see it doesn't have any statistical reason. It just, SPSS doesn't do that earlier. So that's why we have to do a rotation. If you really say that, it's, yeah. Doesn't really happen.
I guess my question is how do we know then that it's really a 0.7 loading for that factor?
That's what the
Compared
SPSS
to
showed
the-
it out.
It's just fixing it because it didn't do it before. That's how they fixed it.
Yeah, because SPSS always
That's
came
how
out
they
these
fixed the
tables.
program I
Yeah.
meant.
And then they just program that for you.
Okay,
Yeah.
it's a software.
Because they look at the correlations and then they find out the highest correlation of the item and the factor, and then they just distribute the
Okay.
item to that factor. Yeah.
So-
Okay, hold on, it's still running.
so the 0.2 originally is a false number.
So is it correct to say for factor 2 items like 1 through 3 loaded high on factor 2?
Yeah.
Is that
In the
what you're saying?
groups,
Yes.
and then you take the ones that were at 0.5 or above.
Yeah.
Yeah. Right, you don't even totally ignore it, yeah.
And then the next thing is actually here, and then we put orthogonal and oblique, is because under rotation there are two types. Because there's a different formula, there's a different computer programming, so that's why there's a two different types. You either follow orthogonal rotation or you follow oblique rotation. And then these orthogonal or oblique referring to the factors. Referring to factors. So if your factors, let's just say our three factors are highly correlated, then we call them, we use an oblique because they're oblique, right? Because they're highly correlated. That's what oblique means.
Hold on.
So then you're gonna use the Promax rotation method. It's on SPSS. Yeah.
Oblique if the factors are correlated.
No, oh yeah, highly correlated.
And is there a cutoff for that, or are you saying like?
Wait.
Oh, there's no cutoff. You just run a correlation for the factors. You
All
don't
right,
even go
so
you just run-
orthogonal, they cannot be correlated.
Yes, orthogonal means there's no
Less than
correlation.
5.
Yeah,
Well, that's what-
point-
that's for
0.5,
example.
yeah. So you run a correlation for factors, which is you run a Pearson R, and if you find out that they have no significant correlation, you use orthogonal.
Use very.
So if we ran a Pearson R and
Yeah, you run the Pearson R for
it would have
all
to be like
factors.
0.8 or above, is
No,
that? how
remember
we
when you run
calculate?
Pearson R, you look at their significant.
Yeah,
If it's not significant, no matter what the Pearson R shows, that means it's not a correlation, significant correlation.
if not significant.
And then you can know that you go orthogonal because
Not.
they don't have correlation.
So you look into the Pearson R to
Yeah.
determine if they are.
Yeah, if the factors are orthogonal or oblique. And then after that, you can choose the right rotation method.
Okay, so you run the Pearson R. If it is significant, then you would use oblique, right?
Yes, because that means they're correlated.
Pearson R is not significant, then it's orthogonal.
So P is less than
Use their.
0.05
Yeah. But what, okay, are you gonna tell us what those things mean? What is that? Is Obleman and Verimax, are those just the names of the
Yeah, it's
tests?
No, yeah, this is the name of the rotation method. You don't have to know what it means.
You don't have to know what that means.
No, you just know orthogonal, you use either Verimax or Obleman, but Verimax is the only thing mentioned on packet.
Yes.
I just know some classes, they use Obleman, so that's why I just put it out. And then for oblique, you only use Promax.
Okay.
Yeah.
So we don't have to know what that means.
Oh, no, you
Okay.
don't. They don't.
Good.
Let this out. Okay, apparently we already covered, so that's all you also need for factor analysis. It's just that the last part is only for factor analysis, not for component, principal component. And the next thing we're going to talk about more about factor analysis because there are EFA, which is exploratory factor analysis, and CFA.
And these are all under factor analysis?
Yes, yeah. So principal component analysis, PCA is done. Now we go factor analysis. But these are all the shared key points between both of them. So just make sure these are all also part of the factor analysis. But then factor analysis has extension. Could be whether you run the EFA or CFA, which you can find on page 76 to page 77.
Okay, now.
I'm just happy that the packet doesn't make it very complicated because otherwise there's a lot of things to talk about there if you can really run it. But the packet only talk about what's the difference between these two, what's the definition of it, and why you're going to use this different factor analysis. So that's why I'm not going to go further than that.
Wait.
Yeah, just look at the packet. Packet didn't go that much complicated. They only talk about the definition of these two, what's the difference of them, and why you're going to use which one. When you're going to use either EFA or CFA. It's on page 76.
Can we go over those real quick? Because I'm a little confused about them.
Yeah, if you just read it, it's very easy to
And
understand.
this isn't a significant part of the comp,
No,
correct?
yeah, it's not
Yeah.
really.
Okay.
Good.
And then if you look at page 77, yeah, they have a factor loading. So they just explain what factor loading means and then what is counted as a meaningful factor loading. So actually, if you look at the last sentence under factor loadings, it said loadings of less than 0.3 or 4 are generally not considered meaningful. So you see, that's why we say 0.5 is kind of like the best factor loading. Which means, yeah, 0.5 is very statistically significant, very meaningful, and very good acceptable items can be loaded on the factor.
0.5 is a good factor loading.
Yeah, 0.5.
But generally you can accept 0.3 or 0.4.
Yeah, but for example, if you find out most of our items loadings are like between, let's just say it has 0.1, it has 0.2, they have 0.3, 0.4, and then 0.5. But if it's under this case, you don't even have any loadings like 0.6 or 0.7. If it's under this case, you can think of, okay, keep the 0.4 and 0.5,
Right.
yeah. But if you have like 6 and 7, you keep the highest one, yeah. Okay. And the last part part is the path analysis as SEM.
So everything that we saw before also is for factor analysis.
Yeah, because the packet doesn't say that much, which is great. I really love that. This is not supposed to give you guys a hard time on that, because you could have like another 20 questions about EFA and CFA.
Oh.
So that's why you don't need to know the details. Okay, path analysis and SEM is on page 65.
Are we lumping them together?
Yeah, because actually they are the same thing, but I'll tell you what's the minor difference between
Okay.
them.
Page what, 65?
Yeah, 65. It's from 65 to 66. You can also find it actually on page 72, page 73. But on page 72, they talk about it as a causal models. So if you go page 72, it's under G. They don't really say it's a path analysis or SEM, but instead they say it's a causal models. But it's the same thing as in path analysis and SEM.
I was wondering about that.
Okay, so actually these two, they're just simply the extension of multiple regression. Because remember when you do multiple regression, you have only one DB. And then you have like one outcome. I'll use the word to not confuse you guys. So you have one outcome, and you have predictor 1, predictor 2, predictor 3, and predictor 4. And you may have like a mediator here. Yeah, mediator. So this is like a simple multiple regression, and you may have a moderator, right? Here. Yeah, you can have mediator here or whatever. So this is like a simple multiple regression. So path analysis SEM extension, meaning what? Meaning when you do path analysis, it's going to be like this. And you don't call them predictor outcome anymore. Remember we call them endogenous variable, exogenous variable. And exogenous is like predictor, and endogenous could be mediator, could be moderator, could be outcome. So when you draw a path analysis, that's what is also showing in the chart. I'll just use letters because we don't talk about predictor.
What do you call them in path analysis? You don't call them predictors or outcomes,
Yeah.
you call them...
Exogenous
page.
or endogenous?
It's on page 66.
Okay.
What's the causer?
So that's why, so you,
Okay, got it.
instead of drawing like this, you're actually going to draw like this. So like, for example, A is our one of the exogenous variable, and the B is another one. So actually you go, for example, maybe to C, and then to D. B also goes to D, and then D goes to E, and then D also actually coming from F, and then C goes to E2, and then finally goes to
G.
G. Oh, yeah.
Okay.
So you see, it's much more completed than the multiple. Multiple regression only have one path. That's it. From this point and at this point. Doesn't have any turnings. So this will be a path analysis or structural Bayesian modeling it looks like. So you see, that's why you see, if you see C is a mediator, which is not correct because C goes to D, goes to E, and finally goes to G. You cannot simply say it's a mediator. Because the mediator is supposed to be mediate only two variables. But in this path, actually have more than two. It's have like 1, 2, 3. So that's why it's more complicated, the relationship. That's why sometimes we call this as a causal model, as explained on page 72.
Yeah, so there would you say E is a mediator between D and G?
No, because you see, E has too many paths directed. You have from C to here, D to here, and then you go also F, D,
Oh,
and
I
E.
see, I see.
Yeah, that's why you don't call them mediator or moderator. That's why A, B are exogenous, C, D, F, E, G are endogenous variables.
Is F exogenous?
Oh yeah, F is exogenous too, sorry. Yeah, so these three are exogenous. Anything doesn't have an arrow before it is exogenous.
What I heard was if there's air going out and no going in, it's exogenous.
Oh yeah, that's the same thing. So we have like 3 exogenous and 4 endogenous variable in this causal model. And then the difference between these two is that these, we also call them observed variables. So that's why you draw a rectangle or a square out of it. Observed means that you can use items to measure them directly.
So the E would be an
exogenous.
endogenous and the G also endogenous.
Yeah, so
That.
endogenous.
All of them are called observed, can be called observed?
They all observed. That's what I'm trying to tell the difference between path analysis and SEM. In path analysis, all these variables are observed,
Oh,
which means you can measure them directly. Like for example, A could be gender, and then B could be age, C, D, E, F. So it's like multiple regression. You can measure them directly, but you just have more complicated path, a more complicated relationship. But SEM is linked with factor analysis. So we don't use observed variables. We use what we call latent variables, which
Wait.
means these variables cannot be measured directly.
I thought SEM was part of path analysis.
No, path analysis, you can say it's not really part of SEM. They're similar because they all study complicated causal model, but SEM use latent variable. Path analysis use observed.
So SEM is related to factor analysis, not path analysis?
Yeah, so actually SEM is a huge thing. So in SEM, you have to do EFA, and then you do a CFA, actually you do item analysis, and then you do EFA, CFA, and then finally you do SEM. So SEM is a way advanced statistical method when you have complicated models and you have latent variable. So when you draw SEM, it's going to be like this. This is A, and that's B, because actually a circle represents latent. And then you go to like C, so that's why you don't use a square, because in statistics, circle represents latent variable. And you go D, and this could be related like this, and let's go E, and then you go F, and then this one goes here, and then finally it goes to G. So this is a SEM. And you can draw like this. You can draw any single path you want. Oh, excuse me, you want. So remember, A here is determined, let's just say it has these items, right? Because those are factors. So it has item 1, item 2, item 3, and item 4, and item 5, or item 6. And then B is the same thing, D is the same thing, C is the same thing, E is the same thing, F is the same, G is the same. So that's why we say A cannot be measured directly. So which means it's not like age or gender here. You can just give them values and measure them. So for example, let's just say A is motivation. And you have 20 items, measure it. So that's why you run a factor analysis to delete as much as unrelated items in your study. Only keep the items that you need for your study. And then do the SEM. And then find out what's the path coefficient here. And then you can test, that's also your hypothesis.
Path analysis also has path coefficient,
Yeah,
right?
so the path here is also your hypothesis.
Okay, so the difference is that, the difference between SEM and path analysis is that SEM is for individual variables that can be observed.
No, cannot.
Cannot be used.
Yeah.
What did I just say? Path analysis is for ones that can be
you can.
observed.
So that's why
Yeah.
it means there's just like single variable.
Single.
age,
And
gender,
then
anything.
SEM is
Latent.
drawing the paths between the factors,
Yeah,
also called latent variables.
yeah. Also, the factors also called constructs.
Can you repeat the latent variables again?
Oh yeah, latent variables means the variables cannot be measured directly, or their values cannot be observed directly or measured by one single value. They have to come out from items.
They include several items.
Yeah, but beyond that, we don't need to know more.
So path analysis is just drawing the path between observed variables,
Yeah.
single observed variables.
That's
and SEM is latent variables.
Latent,
which
yeah,
are
latent
also
variable or
several.
factor or yeah, or constructs.
What about path coefficients or spurious?
Oh yeah, I'll go through it, but I'm just trying to tell the difference because SEM is done. As long as you know how to tell the difference between them, you don't have to know further for SEM. Because in SEM, there is like measurement model, there's a bunch of variability.
Does you also have the other ones? Also have the endogenous and exogenous, or
Yeah.
just, they also
Yeah,
have?
in SEM, we also call them endogenous, exogenous. Yeah. So I'm not gonna write any more detail because if you just look through the packet, it's very easy to know what's the key points in the path analysis. Because path analysis is more important than SEM for the comps. So if you go for page 65, they're talking about what's the direct path means, what's the indirect. So that will be referring to in our ANOVA, we talk about the main fact, interaction effect. So you know that when you do path analysis, you don't say main fact, you say only direct effect or indirect effect.
What, can you say it again?
Yeah, I'm just saying look at page 65 under the path analysis. Just knowing those terms, because I'm not going to write them down. They're not really that complicated to understand.
And indirect, you said is simple. Simple things.
Oh, that's what I'm saying. When you talk about in path analysis, don't mix them up with any facts we talked about earlier for a
Right.
single, like easy parametric test, like in ANOVA, or regression. We talk about main fact, interaction fact, simple facts. Don't link them together.
Okay.
They're gonna name it differently. That's why on page 65 they started to call direct effect, and you know what direct effect means. It means just from A to C. So this is what we call the direct effect. And if you go like this, that's indirect effect, because you go a turn. So actually, if you really can be simulated to multiple regression or interaction, it's like a mediator effect. But instead of to say that, we don't say that because it's technically it's not really a mediator. So that's why we say this as an indirect effect. This is a direct effect.
And that's for path analysis
Yeah.
and SEM.
No, you don't know any more about SEM. I just want to tell you the difference, because SEM doesn't have that much of thing. Yeah. Right now I'm just saying go through path analysis. And if you enter relationship, there's a direct, indirect, spurious, analyze, and the moderators, and the mediators. You just know what that means, how to differentiate it. There is actually one thing that Asher found out a mistake last time when we talked about in multiple regression.
66.
Yeah. So if you look at the spurious definition on page 65 and the spurious definition on page 66, it's different. It's a little bit weird. But on page 65 is the right one. Page 66 is wrong. For spurious.
It's also mentioned on
Yes,
page
'cause it doesn't
66.
reverse it. Yeah.
Okay.
And it says it reverses it.
Yeah,
Okay,
page,
right.
page 65 is the correct one.
It
66.
says it's wrong.
Yeah, 66 is wrong.
Like, what?
Only refer to 65 for the accurate definition of spurious relationship.
Okay.
Oh, yeah, because it didn't work for
Yeah, they talk differently. It's now reversed, yeah. And if you go 72, under causal models, there's something different than the path analysis things on page 65. It's about the recursive versus non-recursive models. Yeah, so actually instead of to say spurious or analyzed, they talk about in the recursive and non-recursive concept or terms.
Saying
But it's-
recursive, where's that?
Oh, it's on page 72.
Oh.
Yeah,
What
because
is
it's
that?
also on page 72, they talk about recursive versus non-recursive models and their causal model. Because causal model is part of path analysis. That's sometimes we call it as a causal model. So just make sure you're also referring to that part, and when you read the packet, that's supposed to be linked together. But then the packet just put them separately again.
You link it with which one?
With path analysis.
Okay.
Yeah, they're supposed to be together. Yeah, but if you look at on page 73, see, they're talking about exogenous direct effects, indirect effects again. So you see, that's why it's part of the path analysis, but they put them in two different places.
Okay. But that's SEM and path.
All right, so we are all done with all the packet contents.
Are we really?
Yeah, we're rolling. Good job, guys.
We're gonna do a review?
Yeah, so right now I want to do, like, what do you want to do it? We can go for the decision tree exercise where I can do the whole overview of the first sessions, including this one. Depends on which order you want it.
Decision tree maybe?
So decision tree? Okay.
Yes.
If it's decision tree, I don't know how much of you have done the test. If you haven't done exercise, that'll be great.
I didn't do that.
It's on page 125 on the packet.
Done.
And you can stop recording, Lucia.
Oh, yeah?
This, yeah.
Decision trees.
I bet for the,
Super Bowl.
Oh, gee.
Okay, guys, let's do the final overview of
Because
the
they win
first
every year.
sessions and including the earlier part of this session. So first thing we'll talk about is research design.
A couple years ago, I would have agreed with you, not this team, with this team.
And in research design, remember, we go through qualitative, quantitative. That's the difference between these two. And then after that, we also have like a third additional research design, which is kind of beyond qualitative, quantitative, called analog research.
why are we going over research design?
We're gonna
That's the first thing.
overall.
Yeah.
She's gonna do the
Okay.
whole test right now.
Oh my
The
God.
whole comp, she's gonna cover
Yeah.
in 35 minutes.
Yeah, that's pretty much, we're gonna,
Qualitative, quantitative.
I won't tell detail. I'll just
Okay.
cover.
Hold questions
Yeah.
till the end.
And then,
So-
and then quantitative, and then we also know that there is three type of research design. There is experimental design, quasi-experimental, and you have the single subject design. So make sure you also read through that on the packet. They'll explain it perfectly. And also we know that there's another type to categorize them, which we call assessing group difference, or we're doing correlation study, or we're doing relation study. So based on that, it's also going to determine what kind of a statistical test you need to use. So if you're comparing group differences, use t-test, ANOVA, MANOVA, and COVA-MACOVA. Correlation, all the correlational, Spearman-Rall, Pearson correlation, point biserial. And also the last one is the relationship study. There's multiple regression, logistic discriminant regression, path analysis, and all the causal models. And also when we talk about research design, there's two different statistics types. There's descriptive statistics and inferential statistics. And after that, we just go to inferential, we go to descriptive statistics first. We talk about the mean, central tendency, median mode, and then we talk about dispersion, variability, which is referring to standard deviation, variance. There's anything else in that? Oh, the frequencies. So that'll be part of that. And after that, we go for inferential, we not go for, yeah, we go inferential statistics. And after that, we talk about, okay, next thing is actually, yeah. So actually after that, we determine whether we go for parametric tests or non-parametric tests. And under inferential, because it's not part of the descriptives anymore. And under parametric and non-parametrics, we separate them into univariate tests and multivariate tests. And remember, univariate refers to one dV, multivariate refers to multiple dVs. And then after you determine that, what kind of statistic go through, and then we go for the data, because it's also part, actually before that, we're supposed to go hypothesis. That's another big thing. Yeah, actually, yeah, non-parametric, parametric. And actually after that, we're supposed to go for hypothesis before that, but it's okay. It's not really a big deal, the order. So hypothesis, we talk about non-hypothesis, alternative hypothesis, and referring to that, there's type 1 error, type 2 error. Make sure now you can tell the true positive, false positive, true negative, false negative. Which one is sensitivity and specificity. So that's part of a hypothesis. And for hypothesis, we also need to know the alpha and beta, which is the balance point for type 1 and type 2 error. Because based on that, we can also minimize the type 1 error and also minimize the type 2 error. Because they are reversely inflated. Which means you cannot largely reduce type 1 error because that could cause your type 2 error increase. So which means we have to find a balance point, which is when beta equals 0.2. Because that's going to also relate to power. Because power equals 1 minus beta, so power going to be 0.8. That is your balance point to get the best results of your hypothesis testing. And then we talk about the p-level and an f-score and the t-score. What's the difference among them? So remember which one is the judge, which one is the jury. And after that, we go for data. Because after you fix out your hypothesis, you can go collect your data. And under data, we call it about sampling. Because we cannot get population numbers, we cannot get population data. So that's why we have to go sample data. So we talk about the random sampling, random selection, random assignment. Make sure you can tell the difference among them. And then we also talk about sampling distribution, but that's another thing we covered later in the section. We didn't cover there, but we covered in the next day because I forgot about sampling distribution. And in the sampling, we also talk about a bunch of errors. We talk about sampling error, standard error, error variance, and the standard error of measurement. And from the standard error of measurement, we're referring to that to confidence interval because those two are connected. And then under confidence interval, we talk about the confidence level 2, and then confidence limits, and the confidence interval of the means. And then when we talk those, you have to be able to tell the difference between the confidence interval of the means and one pair sample t-test, and then 2 sample t-test. And then under data, we do talk about one unique assumption, which is normality, because normality is the only assumptions for data. So we talk about the skewness, kurtosis, box plot, histogram, bar chart, and the normality test. Oh, there was one thing, but it's okay. It's supposed to be, I think it's covered in the packet. We talk about most of them. And after that, we go for non-parametric. Oh, actually, we go for the decision tree. Which is good because we just exercise about it. And then we go for each single test. So first we go the non-parametric test set. And then we go to parametric. So first of all, we tell the difference between non-parametric tests and parametric tests. And also we talk about each single non-parametric test. There's a chi-square, all the weird test name, like non-unit test, fragment test, spear.
That Wallace one or whatever.
Exactly, Cross-Cal-Wallace test. Yeah, all those weird names came out from the decision tree under the non-parametric test, all the under this section. And then because non-parametric test is not really that important, so you don't have to pay too much attention about it. And then we just jump to the parametric tests. So in parametric tests, it's more important because that's also the most tests we'll use for our dissertation, for our research. So parametric test, there is a t-test, yeah, ANOVAs, ANCOVAs, and correlation.
Okay.
Yeah, and then in parametric, we separate them into univariate and multivariate. So remember, univariate 1 dB and multivariate more than 1 dB. So univariate, which means you know this t-test, correlation, ANOVA, and ANCOVAs. And multivariate is MANOVAs, MANCOVAs, multiple regression, path analysis, SEM, canonical correlation. And then we talk about the key point for t-test. T-score, distribution, one tail, two tail, p-level, and then the 3 types, pair sample t-test, independent sample t-test, one sample or single sample t-test. So make sure you know all of those. And then we talk about the effect size. So for t-test, the best effect size is Cohen's d. But if you cannot access Cohen's d, you use the eta squared. And then remember the cutoff value for Cohen's d, 0.3, 0.5, and 0.8, referring to small, medium, and large. And then
The book didn't even have that.
And then the next one, and eta squared, what's the cutoff for that? 0.01, 0.06, and 0.15. That's small, medium, large. And the next one, we go to ANOVA, MANOVA, ANCOVA, MANCOVA. So we go to F-test, F-distribution. And in F-distribution, we talk about degree of freedom. And what's the difference between numerator, denominator, because you need to judge, you need to look at them, yeah, to judge your F critical score. And of course, the p-level. And then we talk about, I forgot that, but we can look at that later. We cannot write. Okay, there we are. I'll talk about that later. I'm sorry, guys. Okay, so in ANOVA, MANOVA, ANCOVA, MANCOVA, and then after the F score, we talk about what's the next thing? Tell me there. What's the next thing for ANOVA?
Regression, we talked about regression after that.
No, we're still in the MANOVA, ANOVA.
Variance, you already mentioned it. So.
Yeah, that's a part of descriptive. I think, yeah, after F score, what
Do you,
I remember
would it
there's a
help
bunch
if you
of
looked
things.
at the outline on the?
No, I don't have it.
She has, she's.
I know her,
I
what
just look
she
at the
did.
packet, yeah. I
Um,
look at the packet and make down the order.
I have yours.
You said effect size, add
Yeah, we talk about effect size, but I remember there's a bunch
sample
of things.
size.
It's okay.
Synthetic variables, those kind of things.
Okay, it's okay. Just refer to packet.
Correlations.
And then the effect size, so in the ANOVA MANOVA, that thing is eta squared. And then when we referring to the 4 different type of effect size, there is omega squared, eta squared, Cohen's d, and r squared. So you just know the difference among them and under which condition you're supposed to use which effect size. And the multivariate we covered, MANOVA is already covered here, so then we just only cover the multi-regression, logistic regression, and discriminant regression. And then path analysis, and then SEM. That's all actually multivariate. So we talk about R square, R, adjusted R, coefficients table, standard, unstandardized, coefficients weights, and then the regression line, and there's a different rules. The Lisa sum of squares, scatter plot, it's all part of regressions. And now, of course, logistic discriminant, we talk about different things, trying to determine the model fit. There's a log likelihood, a chi-square, the Holzmer and Lamshaw goodness of it. Yeah, I forgot to talk about assumptions earlier because before you do any of these tests, before you do the parametric test, you have to check the assumptions first. And we already talked about normality under data. So there's other assumptions, make sure you know them: homogeneity of variance, linearity, homogeneity of regression, homogeneity of variance, homoscedasticity, multicollinearity, sphericity, independence of observation or sampling, level of measurement.
Wow.
Yeah, just refer to your note and packet, it will be all covered there. And then after parametric, and then we talk about validity. Oh, we should go reliability first. And validity. So always check your reliability first because that's the first thing. If you have a low reliability, you cannot make a high validity. So in reliability, there's a 4 type. There is a test retest, there is a parallel or alternate forms, and then there is a homogeneity, internal consistency, and there's the inter-rater. So for this different type of reliability, you have different tests to test it. So there is a Spearman, Brown, Cohen's, Kappa, KR20, Cronbach's alpha. They're like different methods. Just review the packet. It's very thoroughly explained. And then we go for the validity. There is a phase validity, content validity, convergent validity, divergent, discriminant validity, constructive validity. And also referring to the first section under research design on the packet, there's a threats to internal, external validity and constructive validity. But they're all theoretical and definitional. So just make sure you memorize those. And after that, we go through item analysis today. There's kind of like a group. And then principal components, factor analysis, and then path analysis. Yeah. And actually these 2 could be part of the multivariate parametric test. It's supposed to be, but because they're really doing a kind of a different thing beyond these simple tests, so that's why I rather prefer to group them together. Because they're all related. So we go through item analysis, why you're doing it, when you're going to do it, and what's the key components in it, difficulty, discriminability, IRT, ICC. And then we do the principal component analysis. Like remember we talk about the principal component versus principal access. Engine values, communalities, and then rotation is the only thing that difference between these 2. And then in factor analysis, we have EFA, CFA, but they're all very definitional explanation on the packet, so you don't have to know further than that. And then we talk about in path analysis, what's the variables, new names, and then what kind of a causal model is doing, and then there's direct, indirect effects, all the different names of those relationships. And the SEM we just covered a little bit, we just pretty much tell the difference between these 2. And the SEM do latent variables, path analysis do observed variables. So that's pretty much the whole thing. Is there anything I kind of left out?
I don't know.
Yeah, it's fast.
And then the decision tree, you said just line by line or identifying your DVs, IDs, be flexible to change.
Exactly, because
The
when you,
labels
yeah,
as we go.
always remember, first of all, you just don't get distracted by all the others. Just focus on the first sentence. And after the first sentence, you can think about, okay, whether I should introduce more DV, because the question talk about that later, even though they don't put them in the first sentence. But the first sentence, like I said, is the essence. It's like your outline for the whole decision tree question. And after that,
And levels
Go ahead.
levels crossed means just repeated
repeat the
measures.
measures, yes.
That's it,
Mhm.
okay.
Yeah, I wanted to be just consistent with whatever decision tree on the package said, because they said level crossed.
Okay.
Yeah, but it definitely, it means repeated measures.
I would be interested in looking at least one example on the decision tree questions in which the problem talks about mediator or moderator or covariate. We never went over that.
Yeah, because,
And I think I would have a hard time picking out whether or not something's a mediator or a moderator or something like that.
okay, here's some keyword I can show. So for
That'd be
example,
great.
if it's a controlled.
So that's covariate.
Yeah, if you see controlled, it could be covariate. And then like, there's like mediated,
Okay, so it would say mediated.
that would be mediator.
Well, there was one there that said it specifically like
Mediator.
weakened the relationship was strengthened the that's
Oh, that
moderator.
moderator.
Yeah. So pretty much, unless they can go
And
very
it tells you
obvious.
exactly like realize that without this, there's no relationship between this and that.
Yes.
So you kind of know the direction.
Exactly,
You say, you know that if it's mediator or moderator.
And how would that affect what?
Oh,
test
usually
you
it won't,
use?
except for covariate. If there's a covariate, then instead of to say it's ANOVA, you say it's ANCOVA.
Oh, okay.
Yeah, that's the only difference. But for multiple regression, no matter they have mediator or moderator,
Uh-huh.
you just call them multiple regression. Unless the option says multiple regression with mediator, and then you're going to choose that.
Okay.
Otherwise, you just go it's multiple regression.
Always if it's mediator or.
Yeah, mediator moderator only exists in multiple regression.
Okay.
Yeah,
thank
or
you.
logistic regression or discriminant. They don't exist in ANOVA or MANOVA tests.
Okay, so it's multiple regression, logistic regression,
Yeah.
or discriminant
Kinetic
regression.
yes.
Oh, I thought they.
And for covariate, it's ANCOVA or MANCOVA.
Yes, that's
Okay.
right. Yeah, I know Dr. Brown, he doesn't have a distinction of.
really
Yeah.
thought
For
that.
him, mediator moderator can exist in ANOVA or MANOVA.
Yeah, I thought it existed in PCA, but
No, because remember in this we call them endogenous, exogenous.
Yeah,
We don't really
that's
have
true.
mediator, moderator. Yeah, but of course the things that sometimes they say that we're supposed to assess the mediating facts in this, but it's not that important. Yeah, like the mediator moderator specifically identified in the regressions analysis.
Okay.
Yeah,
Thank you.
and I wonder whether they're going to include this in the decision tree question because these are really complicated. If they have to tell you the answers are this, they have to write the question
Path
very, very
analysis,
complicated.
yes. But path
Oh, yeah.
analysis,
I don't think so.
I heard from multiple people that this test is really straightforward from the packet. So
Yeah. Not
it's
converts
not like
confirmed.
a,
I
not
told
like
him like
cognitive.
follows the outline perfectly. He
History
said that
systems
it's-
does well, and then
Do we know for sure if the test is changing yet?
No,
No,
we
it's
don't
not
know.
changing.
Oh,
For sure,
Not.
for sure.
no,
It's the
not for
same.
this time.
Not for
No,
this
yeah,
time.
not for
No,
this.
not for this time, next time.
Next time, he told me that
I think that's up in the air.
possibly the next one would be changed.
I also heard they were thinking about getting rid of
Possibly,
comps.
so we don't
Yeah,
know.
I heard that too.
He said, for sure this one is not, possibly the next
The
one.
thing is, the comps are to prepare you for the EPPP.
Yeah, well, that's
The
what they're.
EPPP does not do decision trees or anything like that.
Mhm.
It's a vocab test. I
Right.
looked at the study guide for that.
Yeah.
Vocabulary.
Yeah, it's like, what is
Concept.
homogeneity?
Wow.
The E-triple-P?
This is mainly concept, what Dr. Givert's, it's mainly Dr. Givert's exam, because he made freaking questions.
Oh. Okay.
I think we'll be
All that
okay.
was
We've
in there
invest-
that didn't have the, the output questions. That's what's gonna be there.
Yeah, we won't have the output.
Yeah, this is the only things. This only
wanted-
3 things I don't know, so that's why I didn't cover it. I didn't talk about it.
Which one?
The test, Remember? It's on page,
Okay.
it's on page 100. Yeah, I just talked through it. I said I don't have knowledge about it because it's very
Oh, the
psychology related.
MTMN stuff?
Yeah, and the MTMM stuff, I don't know anything about it, so these only the 3 sections of the
This-
packet I didn't cover in detail.
This I looked into the Dr. Mono's class.
Yeah, because the table that they gave us for the diagonal tables on here is different than
no,
what she
this-
gave us.
Yeah, no, and I was reading whatever they have for that. It's exactly out of her PowerPoints.
Yeah,
For the
exactly.
purpose of this class, point through, I'm
Uh-huh.
like, that's exactly her
And then
PowerPoint. So
the-
just go there.
The girl said that we'll have maybe one question on that.
Yeah, Rena, yeah, because she took it and then,
Well, but that, again, we cannot, see, it's not the same.
No, it's
They
not
have
the same.
500 questions and the person picks 50.
It's not the
every
same,
year.
but I think they picked the same percentage of each topic,
I don't know.
like 5%.
However they do that, they need to conduct a factor analysis as we discussed.
And an
That's when they
ICC.
determined that that item was, everybody didn't pass, they take it out
And
and they
yeah, an
increase our
ICC.
grade.
yeah, and I forgot to cover here, we talk about variables a lot, like the scales, nominal, ordinal, interval, and ratio. And the variables, there's a different name for it, IV, DV, covariant, mediator. You just know under what kind of a situation you should name them differently.
It's true, because they're gonna probably ask that. So, is this a moderator and endogenous?
And also there's another thing, we talk about power, effect size, sample size, type 1 error, type 2 error, how they are related with each other. Remember power mathematically equals 1 minus beta, which is type 2 error, and also power statistically determined by sample size, effect size, and type 1 error.
You said type 1 error is 1 minus beta? No.
No,
Type power.
beta
It's
equals 1 minus type 2 error.
Yeah,
That's
it's
the
power.
mathematically calculation, yeah, formula for power.
Beta equals 1 minus type 2 error. That's a good way to remember it.
You need 72, right?
74.
74.
Okay.
You'll pass. You'll pass.
Still pretty good about it.
I can tell.
Well, I just need to know the decision tree questions more, that's all I don't know.
It's mostly, it's a lot of that, so.
All right,
According
are
to
we
Dr.
done? Or we
Bird,
gonna
All right,
cover-
thanks, guys.
questions about decision tree.
Yeah, we're done. I'm
He
just,
said it was
Okay,
three or
great.
4
Finish
questions
up.
about decision tree, that's not mostly on it.
Oh, really?
unless you have any further questions.
I need to read.